The first focus is on the weapon systems extending out like dragon heads from the left side of the aircraft. Loadmasters carry 105mm high explosive rounds, each as heavy as a human torso, essentially placing the heaviest blows into the nervous system of the aircraft. These rounds are powerful enough to take out a tank or turn a building into a pile of rubble within seconds. However, the difference of the Ghostrider lies in its ability to pass this raw power through the eye of a needle. Specialists check the fuse, the powder charge, and the center of gravity of every single round as they line them up on the racks. Because when this aircraft fires while turning at a 45-degree angle over its target, the mathematical harmony between the muzzle velocity of that round and the turning speed of the aircraft must be flawless. At those moments, when the shells are stacked into the belly of the aircraft, the sound of metal hitting metal echoes like a war drum. Right next to it, the feeding mechanism of the 30mm GAU-23A autocannon is being prepared. This weapon is the scalpel of the Ghostrider. Capable of sending 200 rounds to the target with a perfect grouping every minute, this system is the key to the most complex close air support missions. Technicians cannot tolerate even the smallest risk of jamming as they place the ammunition belts into the feed chutes. Each ammunition belt glides over special rails in the fuselage to reach the barrel. Meanwhile, feverish work continues around the exterior of the aircraft. Engine technicians perform a ritual around the 4 Rolls-Royce turboprop engines, each producing more than 4,500 horsepower. Engine covers are opened, hydraulic lines are inspected, and fuel filters are checked. These engines do not just keep the aircraft in the air, they also produce the electricity that feeds the massive computers, sensors, and laser designators inside the plane. If one of these engines fails during a mission, not only the thrust, but also the digital brain of the aircraft is in danger. In these images, you can notice how small the personnel remain under the massive wings of the aircraft. However, those small figures are the essential will that brings this 100-ton monster back to life. Each tip of the 6-bladed composite propellers is designed to tear through the air with the least friction and the least noise. Engineers have worked on acoustics for years to ensure the Ghostrider is not heard while at an altitude of 6,000 meters. Even a microscopic scratch on a propeller can disrupt the airflow and ruin that famous silence of the aircraft. This is why technicians review each blade with the precision of a jeweler. The multispectral imaging systems, located just under the nose of the aircraft and referred to as the ball, also come back to life at this stage. Lenses are cleaned with specialized solutions, and gyroscopic stabilization systems are tested. These sensors are the eyes that allow the Ghostrider to track the heat signature of a mouse on the ground, even in pitch darkness or under a heavy dust cloud. One of the most critical moments of preparation is the control of the fiber optic network inside the aircraft. A modern Ghostrider is a flying data center with miles of cables running through it. Every coordinate that falls onto the screens of the weapons operators is transmitted through these cables to the fire control computer, and from there to the weapons with the help of hydraulic arms. In other words, when a soldier pulls a trigger, thousands of parts in the fuselage move simultaneously within milliseconds. This is why every single personnel entering through the open cargo ramp of the aircraft is actually controlling a gear of that massive clock. When the ammunition racks are full, when the engines have passed the final checks, and when all sensors give the ready signal, the famous hydraulic ramp of the aircraft begins to rise slowly. When this ramp closes, the world inside is completely disconnected from the outside. Now, there is only a pressurized cabin, dim red lights, and 9 professionals focused on the mission. These massive machines and munitions you see actually serve a single purpose: to give the message of "you are not alone" to the friendly elements on the ground. The preparation process of the Ghostrider is not a preparation for violence, but the construction of a protective shield. Technical data, horsepower, and bullet calibers are just numbers. However, when these numbers combine correctly, the Ghostrider turns into the most effective deterrent force in the world. As you watch the first vibration of these engines and the first moments when the propellers start to beat the air, you should know that the crew inside the aircraft is now a single body. When we discover the takeoff of this monster and how it sees the world through the eyes of a predator in the next stage, you will better understand why this preparation on the ground is so vital. Now, the ramp is closed, the ground crews have withdrawn, and the deep hum of the Ghostrider has begun to roar on the runway. The mission has officially started. As the ramp seals, the cabin pressurization system activates, and the operational process for the 9-member crew begins. In the cockpit, the pilots cross-check engine data and hydraulic pressure values through the flight management system to enter the final pre-takeoff validation phase. 4 Rolls-Royce AE-2100D3 turboprop engines, each producing 4,591 horsepower, bring the propellers to flight revolutions. When the pilots move the throttles to takeoff power, the 6-bladed composite propellers beat the air with maximum efficiency, accelerating the 100-ton airframe along the runway. As the wheels leave the ground, the flight computer optimizes the aerodynamic surfaces according to the climb angle. During the gain of altitude, the digital integration of the weapon systems mounted on the left side of the aircraft is completed. The fire control computer synchronizes coordinate data from global positioning satellites with the aircraft's inertial navigation system. The Ghostrider initiates the pylon turn maneuver, drawing a circular orbit over the target area. During this maneuver, the aircraft constantly banks on its left wing, ensuring that the weapons on the side of the fuselage remain locked on the target. The pilot crew maintains the altitude and angle of the aircraft with millimeter precision, while the weapons operators in the rear cabin manage the target identification process via joystick controls. The 30mm GAU-23A autocannon, located on the front left portion of the fuselage, constitutes the first phase of the engagement. The barrel is connected to a digital firing mechanism that processes thousands of data points per second. The moment the weapons operator marks the target with a laser, the mission computer calculates wind speed, air density, and the instantaneous velocity vector of the aircraft to transmit the necessary correction commands to the barrel. Upon pulling the trigger, 30mm high-explosive rounds exit the barrel at a speed of more than 1,000 meters per second. Although each shot creates a significant recoil force on the airframe, the flight control software dampens this vibration instantly through actuator movements on the flaps and ailerons. The firing rate of the 30mm system can be increased up to 200 rounds per minute. This weapon is a high-precision instrument used to neutralize lightly armored vehicles and personnel groups. The flames exiting the muzzle and the discharge of empty casings from the ejection mechanism demonstrate the mechanical efficiency of the weapon. Operators track the impact point of the rounds in real time through thermal sensors and the MX-20D imaging turret. The tracer rounds gliding down from the sky provide direct hits on the ground coordinates. The barrel remains locked on the target throughout the circular maneuver performed by the aircraft. This stability is made possible by the most advanced gyroscopic stabilization systems in the world. On the technical side of the process, sensors continuously measure the barrel temperature and the feed pressure in the ammunition path after every shot. If an overheating or a feeding error is detected in the system, the fire control computer stops the firing within milliseconds to ensure safety. Every target reticle seen on the operator's screens is a combination of infrared data coming from the electro-optical sensors under the aircraft. This data allows the personnel to identify the target clearly, even in pitch darkness or adverse weather conditions. Instruments in the cockpit report the fuel consumption of the aircraft and the exhaust temperature values of the engines in real time. Pilots operate the fuel transfer system in automatic mode to balance the center of gravity shifts that may occur during the use of the weapon systems. The digital infrastructure of the Ghostrider allows the pilot to focus on the flight mission, while the weapons operator focuses on the destruction mission. Following the successful engagement of the 30mm cannon, system data is updated for the next and heavier phase of preparation. As the barrel enters the cooling phase after the last shot, the sensors continue to scan for other threats in the area. Within the internal communication network of the aircraft, there is a constant flow of data regarding the status of the weapon and the remaining ammunition quantity. This process, tracked via digital screens, maintains the situational awareness of the personnel at the highest level. The impact of the 30mm rounds on the target allows for the creation of a protection corridor for friendly units on the ground. The technical discipline displayed at this stage is a concrete example of how advanced the aircraft is as a platform. When the precise maneuvers of the pilot and the high cycle performance of the weapon system combine, the Ghostrider turns into a force multiplier that redefines close air support doctrine. As the turn over the mission area continues, barrel temperature and system values are being optimized for the next engagement. Establishing a circular orbit over the target area symbolizes the transition into the most critical phase of the operation for the Ghostrider. Following the initial intervention by the 30mm cannon, mission computers and weapons operators activate the much more destructive 105mm M102 howitzer system. At this stage, coordination inside the aircraft transforms into a combination of data traffic, measured in milliseconds, and physical strength. Weapons operators use high-resolution thermal data from the MX-20D electro-optical sensor turret to lock target coordinates into the fire control computer. This digital data stream simultaneously falls onto the panels in front of the loadmasters in the rear cabin. Loadmasters counteract the gravitational forces generated during the sharp maneuvers of the aircraft, removing the massive 105mm munitions from storage racks and directing them toward the breech mechanism of the howitzer. The loading process of the 105mm howitzer is the most technical and physically demanding action inside the Ghostrider. When the loadmaster manually slides the high explosive round into the mechanism, the breech block closes automatically and transmits the ready-to-fire signal to the cockpit and the weapons operator's screen. Meanwhile, the pilots constantly correct flight control surfaces at a microscopic level to keep the angle and altitude of the aircraft stable. During the pylon turn, where the aircraft banks on its left wing, the barrel of the howitzer remains locked on the target like a laser. The fire control computer continuously updates the aiming reticle by calculating the speed of the aircraft, altitude, wind direction, air pressure, and even the estimated heating margin of the barrel during muzzle exit. The moment the operator pulls the trigger, a vibration much more intense than that of the 30mm cannon is felt throughout the airframe. The recoil system absorbs the majority of this massive energy, preventing the flight stability of the aircraft from being compromised. With the massive explosion of flame exiting the muzzle, the 105mm round reaches the target coordinates within seconds. The destruction impact created by this munition transforms the Ghostrider from just a support aircraft into a flying artillery battery. After firing, the breech mechanism opens automatically, and the empty casing is ejected along with hot smoke. The loadmaster slides a new round into the mechanism within seconds, ensuring the continuity of the firing cycle. During this process, coordination inside the aircraft must be flawless. A 1-degree deviation in the pilot's banking angle, or a delay in the loadmaster's loading speed, directly affects the precision of the shot and the rhythm of the operation. Operators perform damage assessment on the target via thermal cameras after every strike, and enter coordinate corrections into the system instantaneously if necessary. The precision-guided munition capability of the Ghostrider is supported by munitions launched from tube-type launchers located in the rear cargo section of the aircraft, in addition to heavy guns. These systems allow the aircraft to operate over a much wider area of effect, not just to the side. However, the heart of the operation always beats in that rhythmic munition loading and firing cycle. Only technical confirmations and coordinate data echo within the internal communication network. When the loadmaster gives the ready command, the weapons operator validates the reticle on the target, and the cycle begins again with the fire command. Tracking of each round in the ammunition racks is done automatically through the digital inventory system, and the remaining ammunition information is reflected on the screens in front of the pilots. This is the most fundamental data determining how much longer the aircraft can remain in the mission area. Data synchronization inside the aircraft during operational moments becomes even more complex with radio and data link connections made with friendly units on the ground. Digital target marking data sent by Joint Terminal Attack Controller, or JTAC units, is transmitted directly to the mission computer of the aircraft. In this way, the weapons operator sees exactly where the unit on the ground wants the fire to be directed as a marker on their own screen. This integration is the greatest technological advantage of the Ghostrider to prevent friendly fire and ensure maximum precision. The 30mm and 105mm systems can engage different targets simultaneously. This situation brings the processor load inside the aircraft and the concentration of the personnel to a peak. While the electronic warfare officer constantly monitors the defense systems of the aircraft to stay ready against potential surface-to-air threats, the flight engineer supervises engine values and the health of the mechanical systems in the ammunition path. From a technical perspective, a millimeter scale shift in the center of gravity of the aircraft occurs after every single 105mm shot. The mission computer balances this change through automatic transfer between fuel tanks, ensuring the aircraft continues to turn with perfect stability. When the barrel temperature approaches critical levels, the system automatically calculates cooling periods and warns the personnel. Loadmasters apply standard operating procedures in the placement of every round. Scratches on the casing of the round or irregularities in the fuse mechanism are constantly filtered through sensors and manual checks inside the aircraft. This is an engineering discipline where gunpowder and steel are managed with the highest technology, leaving no room for error. As the final stage of the operation is reached, all weapon systems have been used with maximum efficiency, and the threats on the ground have been neutralized. While the Ghostrider performs its final turns over the target area, sensors scan the region extensively to track secondary explosions or moving elements. Personnel secure the empty casings and move the ammunition systems to the locked position. The fire control computer records data from all engagements made, the amount of ammunition expended, and strike precision statistics. This data is of vital importance for the analyses to be performed after the mission. When the pilots bring the aircraft out of the pylon turn and into a straight flight path, the engines are pulled into a lower fuel consumption mode. At the end of this process, the Ghostrider has extracted the unit on the ground from the circle of fire using all the capabilities it possesses as a platform. There is no other flight operation where engineering, piloting, and physical strength are so intertwined. The power expended by the loadmaster while sliding the round into its chamber, and the precise touch of the weapons operator on the joystick are parts of the whole that make the Ghostrider the most effective aerial platform in the world. This continuous presence in the sky is not just a technological superiority, but a product of the high discipline possessed by the personnel. As the barrels begin to cool and the aircraft enters the return route, the Ghostrider once again takes its place among the clouds as a silent and deadly ghost.